All right, ladies and gentlemen, we are with a live studio audience of 6th Hour Honors Geometry Blended. Woo woo! All right. There we go. Got some crowd noise. So we need to solve for a missing angle here. As you see, it says find the measure of angle B. All right, that's this bad boy right here. So we're gonna, well, we can actually just use B as our letter. That'd be useful. All right. Now we haven't solved for an angle yet in our law of sines adventures here, but we finna gonna do that today. All right. So for my law of sines, I need to set up at least 2 ratios for my superproportion. Anybody want to take a gander at the first one?
Sine C.
Okay, well, sine of 47?
Yeah.
All right. So I'm going to put sine of 47 here, and then what would be my side that goes up on top? 11. So 11 over sine of 47. Whether you do sine of 47 in the numerator and 11 in the denominator, or what I have written here, does not matter as long as you are consistent with the next one. All right. So then what is going to happen in that second proportion? What over what? Allie? Not sure. John?
You have 10 over sine B.
Perfect. 10 over the sine of angle B. So my initial process will be the exact same. I will be, whoop, that didn't work. Uh-oh. All right, now we've got a little more room to work. Let's see here. So the initial process is going to be the same where we cross multiply. So we'd have 10 times the sine of 47 equals 11 times the sine of B. All right. What do I need to do after to try and get B alone? What's the next mathematical move here, children? Sammy? Divide by 11. And I'm just going to keep working like this and not plugging into my calculator yet. Some of you might like to work in your calculator along the way. Some of you may not. So now I have 10 times the sine of 47. I'm going to put this in parentheses so it looks like what I'm going to plug into my calculator. Over 11. And this equals the sine of B. How do I get B by itself? Right now I've got sine of B. How do I get rid of that sine? Sammy, you want to roll?
The inverse.
Yeah, so if I take the sine inverse of the right-hand side, that cancels out the sine. Whatever I do to one side, I got to do to the other. So in my calculator, I will plug in this whole mess. Or I can do it along the way. So as I plug this in, I've got, actually I'll do it in pieces parts. So I'd have, if I did the inside, I'd get 0.66486, blah, 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 blah. And then I can take the sine inverse, or I could plug it in all together. Either way, I should get B equals about 41.67 degrees. Check yourself before you wreck yourself. Plug it in your calculator, whether you do it all at once or you do it in pieces parts. Make sure you're getting that same exact answer as 6th Hour Honors Geometry Blended just got. That was awesome. Rafe, what do you think about that one, brother?
Good.
He thinks good. Okay. Samesies. Retweet, in fact. All right. All right, so we got Trippy Red is taking a walk and wants to figure out how tall a flagpole is. He observes an angle of elevation of 35.2926 degrees to the top of a flagpole. He walks 500 feet and observes an angle of elevation of 43 degrees. How tall is the flagpole? That's what we want to know, Jake. Yes, Jake is excited about this right now. Are you excited about this, Jake?
Not really.
He is. He said, yes, really. Okay. So we should probably draw this out. This is very similar to the ones that we did with right triangle trig, but we can do it with non-right triangle trig, and you may find it to be a little bit easier. So we've got ourselves some kind of a flagpole. We want to know how tall that is. We know that he is he's walking, and then he's, 500 feet? He walks 500 feet and takes another reading for the angle of elevation. So we've got 35.2926 degrees, and I've got 43 degrees. Cool. And that is a right angle. Hopefully, if the thing is constructed properly. Yes? Lovely. All right, so I want to figure out what x is eventually. And we could do the whole business of what we've done in the past with all of our tangents and whatnot, but we could actually do some of this with non-right triangle trig, which is super wonderful and rad. Yes, it is, Jake. Yes, it is. He's shaking his head. Yes. He loves this. So I have a question for you. First up, what would this angle be right here? Any thoughts as to how I might find that angle? Emily!
Supplementary angles.
Supplementary angles indeed. 180 minus 143 is 137, right? I like it. I like it. That's cool. Alrighty. Now, right at this point, I've got a few pieces of information. I've got this angle right here, this side, and I've got this angle. Could I figure out this angle up here as well? I got two angles out of a triangle. Could I figure out the third angle? Yeah. What should all the angles add up to in a triangle, Jake?
180.
180 is correct. So if I've got 35.2926 and 137, and I can subtract that out of 180, I end up with, oops, I need a pen to write, 7.7074. Cool. All right. So I've got a side and an angle across from that side. Our law of sines formula will be wonderful for this type of a situation. Don't you think, Sammy?
Yes.
I agree as well. All right. Now, let's talk about our goals here, our mathematical life goals. If I am wanting to figure out what this guy is right here, wouldn't it be real nice and easy if I either knew what this side was or what this side was right here? Yeah, because then I can just soak a toe my way out of this bad boy, right? If I knew this side, I could just do tangent of 43 is equal to x over whatever this side is. If I knew what this hypotenuse was, I could just do sine of 43 is equal to x over whatever that hypotenuse is. Well, in this non-right triangle that I've got going on here, I could figure out this side length using law of sines and then soak a toe my way out of it. So I can use a combination of non-right triangle along with right triangle trigonometry. So I'm going to set up my law of sines real quick. Ooh, let's use purple. That looks like fun. Okay, so I'd have 500 over the sine of 7.7074 is equal to, and then if I want this side right here, y, which angle is across from it, the 137 or the 35.2926? Crickets. Crickets. Which one, Jake?
35.2926.
Very good, Jake. 35.2926. I appreciate it, man. I really appreciate it. So that's my y, and I'd have the sine of 35.2926. So when I calculate this, I'm going to go sine of 39.2926. I'll multiply that by the 500. And I get 316.64 something. And then I would divide that by the sine of 7.7074. And I end up with 2,360.976857. All right, so I'm going to jot that down right here. But I'm going to keep it in my calculator because I live by the words of, or the motto of YORO. Do not forget YORO. You only round once. Isn't that right, children? So Mr. Allen's going to keep that in his calculator for use later, but 2360.976, so on and so forth, right? It keeps going. But I'll just jot that down in my work, even though I'm leaving the more accurate one in my calculator. Isn't that right, Jake?
Yeah.
Heck yeah. All right, so now what can I set up with the information that I have here? What can I use? What kind of math? Crickets. John!
Cross multiplication.
Ooh, we already did that. We already did that right here. You may have been working on another math problem. You're multitasking. So we already did that to get this guy right up here. So now I've got my hypotenuse of this right triangle. I want, well, if I know if this is 43, I want my opposite side. What has opposite and hypotenuse with right triangle trigonometry?
Sine.
Sine. I can set up a sine function. So I'll do sine of 43 is equal to x over 2,360.97 something, so on and so forth. Cool, cool. So how do I solve this?
You divide sine 43 by 2760.97.
I'd actually be multiplying both sides, right? So I'm going to multiply both sides by this bad boy right here. So in my calculator, since I have my calculator storing that number, 2,360.97, blah, 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 I can just hit multiplication, right, times sine of 43. And that should give me my answer of 1,610, oops, 0.18 feet. Bippity bop. You just don't stop. There we go. Those decimals were just wonderful. I had a plan to have it work out in a certain way. It didn't work out how I planned. I tried to do that in the last 3 minutes of lunch, and it's unfortunate that it didn't work out. I was going to try to have it work out as a song title of his, but bummer. Mr. Allen's so sad right now.
What was it supposed to be?
I don't even remember. There are a few of them. Anyways, all right, bye.